Okay, class. Today we will be learning about the product rule and why it works, and then we will be doing a few examples.
Well, some of us already know the product rule.
That's true, but do you understand where it comes from or why it is a general rule in calculus?
Well, no, but I do know that you use it when you're trying to find the derivative of two functions that are being multiplied.
That's a good start. Why don't you explain that to the class?
Okay, well, let's just say that you have two functions, f and g. The product rule states that the derivative of these two functions multiplied together is the derivative of f times the function g plus the derivative of g times the function f.
Very good, but now let's dig a little deeper into why exactly the product rule is the way it is and why it actually works as a general rule.
Ugh, do you mean let's do a proof?
Yes, exactly. Let's start by looking at this derivative in a different way, using the limit definition of the derivative. However, we will need to make a few adjustments in order for this to help us understand how the product rule works. In order to split up the derivative in a way that will help us understand the product rule, we need to both add in and subtract out the expression f of x plus h times g of x to the numerator.
I thought you can't just add whatever numbers you want into equations. Doesn't it turn into something else?
In this case, no, because we are both adding in and subtracting out the same thing. So in this way, it's really just like adding in a zero.
Okay, fine. What's next then?
Now we can break up the limit into more manageable pieces. Any ideas on how we can split it up?
Well, I know we're probably going to have to factor some things out. I don't think we can split it up as it is.
That's true, we are definitely going to have to factor.
Well, I think on the left side we should factor out f of x plus h, and on the right side we should factor out g of x.
That sounds good. Let's give it a shot. That seemed to work. Now let's split it up and rewrite it again.
Oh, now we can use the limit property.
That's right. How would you suggest we rewrite it now?
Like this.
Right. So now we're basically almost done proving why the product rule works. Now we are left with four separate expressions within our equation. This can be represented as g prime of x, and this can be represented as f prime of x, since these are really just the limit definitions of the derivatives for g and f respectively. What should we do with the other two limits we are left with?
Well, the limit as h goes to 0 of g of x is just g of x, since the limit of a constant is just the constant. And the limit as h goes to 0 of f of x plus h is just f of x, because h will go away as it gets to 0.
Very good. So now we can use those four things, f prime of x, f of x, g prime of x, and g of x, to replace the four expressions in our other equation to get the finished product rule. The derivative of f times g equals f of x times g prime of x plus g prime of x times f of x.